for me, please? It doesn't matter who, Kyle. Thank you. Yes, thank you. I appreciate it. All right, so today is Wednesday, March the 2nd. You've had plenty of time to get your warm-up done. We are going to I'll just go over how to do the warm-up just in case you have forgotten how to get those answers. And then we're going to be going right into adding and subtracting polynomials. We got to talk about the degree of polynomials. So today our focus is polynomials. Okay, hopefully we'll get to do some practice with it. Okay, our tutoring today is virtual at 3 p.m. We have Wednesday homework. Please make sure that you review notes. Are there any questions about the homework? Does anybody need me to make a homework help video? You need one for which day or all days?
I was just looking through Wednesday.
Wait. Yes, baby.
Can you do one for yesterday's homework?
I can. So Tuesday? Anybody else? So just Tuesday? Yes.
Do we just do Wednesdays and forget about this?
I'm getting ready to tell you what to do. Yeah, I'm going to tell you. All right. Any questions about that part? All right. Let's turn over. So I do want you to do some problems. Let's see. The ones from Thursday, we're going to do Thursdays tomorrow. Just to let you know, we're going to do it in class, okay? All right, because we hadn't done that yet anyway. So we can do that in class. Any questions, comments, or concerns? All right. Let's look at the warm-up. Let me show you the process. All right, the first problem, the population of Leavetown is 123,000 and is decreasing at a rate of 2.375% each year. What kind of function is this? Linear, exponential, quadratic? Yes.
Exponential.
It is exponential. How do you know that this is exponential? Yes.
Because there's percent.
Okay, because it's growing or decreasing by a percentage. Okay, so is this exponential growth or is this exponential decay? Yes, it's exponential decay. So what formula are you going to use for exponential decay, Kyle?
Y equals E parentheses 1 minus R.
Very good. To the what?
X power.
To the x or t power, okay? So here it says when the population of Leavetown drops below 50,000 to the nearest, okay. So when does it drop below? When is this total below 50,000? So we want to write this as an equation. And then we're going to type it in the calculator and use the calculator to determine how long does it take for it to drop below 50,000, okay? Move my cursor out the way. How would I write this as an equation? What's going to be my C in this problem? Somebody different? They've responded? Yes.
123,000.
123,000. Parentheses what?
0.9765.
And then to get that number, what you do is you say 1 minus, you move the decimal over 2 spaces.
0.02375.
Very good. So 2 spaces, that's going to be 0.02375. Okay, and then when you press enter, that gives you this. So here, that's 97625 to the x power. Okay, so we're going to type this in the calculator, okay, so that we can look at our table to see when or how long is it going to take for the population to drop down to 50,000, okay? So now where do we go to type in an equation? Yes, y equals, good job. So we go to y equals and we type in 123,000 parentheses, that's times 0.97625, and then we got caret key x, okay? All right, make sure you type that in so that you can look at the table. Type it in. Yes, baby. Yeah, that's fine. Just make sure, is that one broken?
No,
Can you put it on my desk so I'll know that I need to fix that one too? Thank you. Okay, everybody got it typed in?
No.
No. Don't you okay? Okay. Did you get it typed?
Yeah.
Okay. All right. So now, what buttons do we press so that we can view the function table? Yes.
Second graph.
Second graph. Good job. So we go to second graph, and now we're gonna keep going down to see at what point is it below 50,000, right? And what was the starting each year decrease? Okay. All right. So keep going. Anybody get there yet?
38.
Y'all got to 38? Okay. Yep. Okay. It takes all the way to 38 for it to drop below. Okay. So here we're going to say, and they said round to the nearest year, so it's 38 years. Okay. Yes, baby.
Can I get a number?
Yes. And what time is it, y'all? I don't even know what time it is. Okay. Yeah. So, 38 years. Okay. It takes 38 years for it to drop down below the 50. It says, what will the population be 100 years from now? Oh, Jesus. So we want to type in 100. So go second window, and I would just type 100 right there. Start at 100 because that's what we're looking for. And then do it like that. So that's what it would be 100 years from now. So what's that?
11,118.
Yep, 11,118. Okay, so that's what it would drop down to. All right, did anybody get any of that on their own? Okay, that's good. All right, a student who waits tables at a restaurant orders, recorded the cost of their meals and the tip that's left by diners, okay, or customers. Use the calculator to determine the line of best fit. So you have to type this in the calculator. Where do I go? I'm gonna clear my calculator. Second plus 7, 1, 2. Where do I go in the calculator to type in ordered pairs or table? Yes.
You go to second. Well, not second.
Stat.
And then enter.
And then enter on edit, okay? And then your L1 values, this is where you put your X. This is where you put your Y values. Okay, so that's going to be my X values. That's going to be $4.75, then $6.84, then $12.52, then $20.42, and $8.97. Okay, so then arrow over, and then for the tip amount, this is 50 cents. For the next tip amount is 90 cents. Then you got $1.50. Then you got $3. And last you have $1. Okay, so after I type that in, where do I go in my calculator to do my line of best fit? Stat, and then what's after that? Calc, and then lean reg. And then we're going to press enter there, right? So since we're talking about money, we only need 2 spaces behind the decimal. So the 2 spaces behind the decimal is going to push us right here at 5. Is 5 going to stay at 5 or go up to 6? So that's going to be 16 cents, right? So this is going to be y is equal to 16 cent x. All right. And then we have our starting amount is going to be a negative what?
Negative 3.
Which is 30 cents. So that's minus 30 cents. Okay. So it says if the diner or the customer orders a meal costing $10.50, how much tip? So we need to figure out how much the tip is going to be. So that's y, right? So we got y is equal to 0.16 times the $10.50 for the X, that's the cost of the meal, minus the 30 cents. And then when we type that in, that's going to give us how much the tip is going to be. Any questions, comments, or concerns? Okay. All right. Let's go ahead and put that up. We are going to do the warm-up tomorrow. If you want to go ahead and do that early, that's fine. But we are going to do the warm-up before we submit this assignment. Is there anybody that's lost? Okay. All right. Okay, let's go ahead and take out our notebook, please. We'll pause for the call. This is going to be page 22, continued. Page 22, continued. All right, so backing up just a little bit, we talked about polynomials. We talked about the fact that the reason why we're going, it looks like we're doing two separate topics, but we're not. You have to understand polynomials before you can solve a quadratic function, okay? And solving a quadratic function, all you say, it's just a line. Solving it simply means that you figure out where the line crosses the x-axis, okay? And so you can do that by hand if they give you the equation, or you can do that in the calculator. It's many different ways that you can figure that out, okay? And so in order to get to that place, you got to understand polynomials, okay? So that's why they put all of this in the same unit. All right, so the first thing that we need to know is, how do you find the degree of a polynomial? How do you find the degree of a polynomial? Okay. And the degree is basically the total number of exponents that are in that term, okay? So in order to find that degree, you add the exponents of the variables together for that term. Add the exponents together. Okay? Add the exponents together for just a single term. I need to put that. Okay? So you don't add the exponents to all the terms together. It's just for one single term. And remember, terms are separated by addition or subtraction signs. All right, so let's do some examples so that you can see how to do the degrees of a polynomial. So let's do an example. Your first example looks like this. This term is 5m to the fifth n to the second. So the degree here, and degree of a polynomial is just saying what's the total number of exponents of that term. That's all a degree is. So I'm going to add the exponents together, 5 and 2. So when I add 5 plus 2, my degree here is going to be what? 7. My degree is 7 for this monomial. Any questions about that? Yes.
So that's what they'll ask.
They'll ask for the degree of that monomial. Yes.
Okay.
And so that's how you find it. Just add the exponents.
Okay.
You okay with it?
Yeah.
All right. You'll probably understand it better as we do more examples, okay? We got 10w x y to the third. And notice I'm only counting the exponents that are on the variables, not exponents that are on numbers, just the variables, okay? So I'm looking for the degree here, okay? Let's look for the degree again. The degree here is, and we do what? What do we add together?
3.
The What's the exponents on the other variables?
1.
This is 1. If you don't see it, this is 1 if you don't see it. So what are you adding together?
3 plus 1 plus 1.
1 plus 1, same thing, plus 3. Very good. And so what does that give you? That gives you a degree of 5. Any questions about how we got 5? Okay. Let's do this last example and then we're going to move on. Let me not separate it, save me space. All right, so let's suppose I have just the variable x. What would the degree here be? What is the degree here?
1.
It's just 1. The degree here is 1. Okay, the exponent here is 1. Are there any questions about that? Now we're going to do how do you find the degree of a polynomial where there's many terms? Okay, not just one. This is monomial. Now we're going to do a polynomial, which could be 2 or more. All right, so let's do this. How? I'm going to write down some steps to help you. How do you find the degree of a polynomial? Okay.
Would we put mono for the first?
You can, we know these are monomials, but you can do monomial here. Make sure you catch up when you come back, okay? All right, so let's write down the steps so we don't get lost, okay? The first thing that you're going to do, and I probably should say steps, y'all. So when you looking back at your notes, you'll know these are steps. The first thing that you're going to do is you're going to find the degree of each term. You're going to find a degree of each term. Okay? Secondly, you're going to take whichever term has the highest degree, that's going to be the degree of the whole polynomial. Okay? Whichever term has the highest degree, that will be the degree of the entire polynomial. Okay, that will be the degree of the polynomial. And then we're going to do an example. We'll pause for the calls, give you a chance to catch up. All right, so let's do an example. Okay, so the example is this. What is the degree of the polynomial? So here we go. Let's do this one. This polynomial, it's going to be 1, 2, 3, 4 terms. So we got the first term at 10x y to the 4th power. The second term, remember, separated by a plus sign, is 8x to the 7th power. Plus, the next term is 6x to the 3rd. Let's do minus x to the 9th. Okay? So now we are going to follow our own steps. Find the degree of each term. So let's do this one first. What's the degree of this term right here?
5.
5, because we say 1 plus 4 is 5. Very good. Any questions about how I found this degree of 5? Okay, let's do this term. Remember, terms are separated by addition or subtraction signs. What is the degree of this term right here? 7, because the exponent here is 7. Okay. Are y'all okay with that? You okay? What is the degree of this term right here? 3, because the exponent here is 3. You're just adding the exponents together. Are you sure you understand what I just said? Okay. And then this last one, what's the degree of this term here?
9.
It is 9. Okay. So now the second is whichever term has the highest degree, that will be the degree of the whole polynomial. What's the highest degree here?
9.
It's 9. So the degree of this polynomial is 9. Degree of polynomial is 9. Okay. And why is it 9? Since 9 is the highest degree, that's why. Since 9 is the highest degree. I'll put an arrow. Because 9 is the highest degree. Any questions about that? Let me slide this down. And I'll pause to give you a chance to write. All right, let's move it. So now we're going to put these, we're going to put the degree, or put the polynomial in order. Okay. What order?
This 22 continued.
Yeah, it's still the same thing. Thank you for saying that. What order do you write a polynomial? Please make sure that you save your notes for next year, because you're going to see everything that we did. You're going to see it again. Because when I tutor people in high school, because I have my own tutoring business, they do the exact same things that we do. So save your notebook, because you're going to see this stuff again, especially in math 2 and yeah, both of them, math 2 and 3. Okay, don't throw it away. You're going to see it again. All right, here we go. The examples here. We're going to order from least to greatest, okay? Actually, when you order by degree, it's greatest to least. I'm sorry. And when you order by degree, it's always going to be from greatest to least. So we're going to follow the same procedures again. We're going to find the degree of each term, and then we're going to put it in order by degree, greatest to least. So let's do this first one. Let's do example. We might do 2 examples. We got the first example, we got 5x to the 4th power plus 4xy minus 6x to the 3rd plus 7 plus 8x to the 5th y. Okay, so we got 1, 2, 3, 4, 5 terms separated by addition and subtraction signs. So first step, what we're going to do, step 1, is we're going to write the degree for each of these. So step, just in case you forget as you're writing if you go back and reading your notes, step 1 is going to be to write the degree for each term. So we're going to write the degree for each term. All right, so let's look at this first term. What's the degree for this first term?
4.
It is 4. Great job. Let's look at the second term. What's the degree of this second term? 2. We add 1 plus 1 is 2. This third one, what's the degree of this third term?
3.
3. Good job. Okay. This term, what's the degree of this term?
1.
0. Remember, it's just the exponents on variables, not numbers, okay? And this last one, what's the degree? 6. Any questions about how we found a degree? Now, if we were finding a degree of the whole polynomial, what would that degree be? It would be 6 because it's the highest one, okay? So now we're going to put this in order from least to greatest. How would we write this? The one with the highest degree goes first. So which term is going to go first based on degree? This one right here, which is what? 8x to the 5th power y. So this goes first, and it's a positive, okay? Make sure you take the sign with it. All right, so what's the next highest?
4.
It's 4. So this is a positive. Okay. What's the next to the highest?
3.
3, and it's a negative. So this is minus 6x to the 3rd. Then what's the next one?
2.
Oh, yes, this one right here. So this is plus 4x y. And then what's the last?
0.
Which is
Plus 7.
plus 7. And it's a positive 7. So this is the order. A lot of times when you have your answer choices, you'll see it written in this order. They mostly put it in order by highest degree. Any questions about that? Not all the time, but most of the time, yes. Okay. Anybody lost? Sure? Good. All right, these are very important vocabulary words that you have to know. So I'm going to go ahead and write these down for you. We got coefficient. What's coefficient?
The number next to the variable.
The number in front of the variable. Does anybody know what a variable is? An unknown number. It's a letter that represents, or it could be a symbol. It's crazy, but it could be a symbol. A letter or symbol that represents an unknown number. An unknown number. I'd be dangerous if I could spell. The computer handicaps me because it automatically auto spells everything. It's awful. Constant. I used to get out of spelling the first round, whatever word they gave me, I'm spelling it wrong. Constant. What's constant?
The number that has nothing attached to it.
Very good. The number that has no variable attached to it. Okay, and I'm gonna pause for the calls, give you a chance to catch up. So we're gonna go, this is gonna be page, what did we say? Page 23. And now we're adding and subtracting, and we're gonna paste this down as page, the sheet that I gave you, you're gonna paste down as 23 as well. So this is Q3, page 23, and this is adding and subtracting polynomials. Take your hood off, babe, as you go. Oh, I thought you was leaving. Never mind. All right, so this is how you add and subtract polynomials. You're gonna, really what you're doing is combining like terms. like terms must have the same variable and the same exponent attached to that variable in order to add or subtract them. Super important. Like terms must have the same variables, plural, because it has to have the same variables. If it's ABs, both of them have to have AB. Must have the same variables and exponents attached to those variables. And exponents attached. They have to be the same. If it's not the same, you cannot combine them together. All right, we're going to do an example. All right, you have 5x to the second plus 5x minus 1. And you're going to add that to 6x to the third, x to the second, plus 6. Okay? There are multiple ways that I can add these together. I can just think of it as I'm going to add the like terms together, or I can work it out vertically. Okay? All right, I'm going to show you both ways. We are going to add only the terms that are actually, no, I'm not. We're just going to combine like terms, okay? So you can't combine these two together within the parentheses because they're not like terms. Why are these not like terms? Because the exponents are different. So that's why you can't combine those together. What about in this parentheses? Can you combine these two terms together? No, because the exponents are different. So now we're going to add this trinomial or polynomial to this trinomial or polynomial. So the highest exponent in both of these is this one, right? Is there another x to the third power over here? No. So we're going to write x to the third power. The next to the highest is to the second power. Is there a term that's like x to the second power? Yeah, where? Right here. So we can add these together. What number is in front of this x to the second? This one's 5. What about this one? 1. So when I add those together, what do I get? Positive 6 what? No. 6x to the second. I'm adding it's 5x to the seconds here and 1x to the second here. So how many x to the seconds do I have? 6. Okay. You got it? Over to the side, you have 5x to the second plus 1x to the second. So how many x to the seconds do you have? 5 plus 1 is what? It's 6 of those x to the seconds. Do you see that or no? What is confusing about it?
It's confusing that, I'm trying to add the extra.
No, because that's multiplying.
Oh, okay. That makes sense.
Okay. All right. We just want to know how many x to the seconds do we have? And we have 5 of them. And then how many x to the seconds over here do we have? We only have 1. So we have a total of 6 x to the seconds. Okay. All right. We did those. What about this one? It's by itself. There's not another one that's like that. And then what about the constants? What is this going to be? Positive 5. So all you're doing is just combining like terms. That's all you're doing here. Any questions about what I just said? How do you know what to do with them? This sign in the middle says you're adding. If it's subtracting, you're going to subtract them. Let's do another one, number 2. Let's do over here, we got 3. Let's do x to the 5th power plus, let's do 2x to the 2nd power minus 3 plus, let's do x. And it's not in order by degree because this should technically be last, but sometimes they do that. We're going to add again. I'm going to do another adding one. And over here, we have 8x to the 5th power plus 3x to the 4th minus, let's do 2x to the 2nd. And let's leave it like that. Again, we're combining like terms. We're going to do highest degree first, okay? What's the highest degree here?
X to the 5th.
Is there another one like that?
Yes.
Yes, and it's this one. Do you see that? We're adding those. I'll write it out to the side for you. 3x to the 5th plus 8x to the 5th. How many x's to the 5th do we have?
11.
It's 11x to the 5th. So we got 11x to the 5th. Any questions about that? You can mark those out. All right, what's the next highest degree?
X to the 4th.
X to the 4th, this one. Is there another one like that?
No.
No, so we got plus 3x to the 4th. Anybody lost? Mark that one out. What's the next highest degree?
2.
Okay, very good. So it's this one right here. Is there another one like it? And it's this one. So let's add those together. We got 2x to the 2nd plus a negative 2x to the 2nd. What does that give you? 0. Do you see that? There are no more x to the seconds. Any questions? Okay. What's next? Plus x. Is there another one like it? No. What's next? Minus 3. Is another like it? No like terms like that one. And this is your answer. Any questions about that? Let's do subtraction. Let's do 6. Let's do n to the 7th minus 2n to the 4th plus 4n. Let's subtract. Let's do 5n to the 7th minus 6n to the 4th plus, let's do 7. You're welcome. All right, so now let's subtract. Kirsten, sit up, babe. You okay? You got it? Okay. All right, so let's do this to the side. We got 6n to the 7th minus, what's the other term that's like that?
5.
Very good. Minus 5n to the 7th. How many n to the 7s do we have?
1.
We got 1 n to the 7th. And all we got to do is just write n to the 7th. So we did this. What's the next to the highest?
4 to the 4th.
N to the 4th. So this is a like term. Is there another one like it?
Yes.
And that's here. So let's subtract. We got negative 2n to the 4th minus a negative 6n to the 4th. How many n's to the 4th do we have?
4.
Not negative 8. Positive 4. Y'all forgot. Minus a negative is what? Is plus a positive. So this is going to be positive 4n to the 4th. So this is going to be plus 4n to the 4th. All right, and then what's the next one?
Plus 4n.
Plus 4n. Is there another like it? No, it's not. And then what's the last?
Plus 7.
Plus 7. Any questions? All right, so now the sheet that I have given you is the sheet that I want us to work on. And this is also, we're going to paste this down when we're done, but this is also page 23. Row 1, please put your calculators back.
Don't do it yet.
No, don't glue it until you finish.